Hey everyone, it's been a while. I mean, right now I'm getting set up because I'm streaming on Twitch and on YouTube and on X, so just like to make sure everything's actually working. It seems like we're good for the most part. Let me, sorry, see me extending my neck. So let me make sure I can see everything correctly. Also pull up a new window. There we go. This might take a second. It's been a while since I've, done this, so I appreciate the patience. There we go. Okay. I have another screen, so this way I can actually look at the chat. Versus like usual, I'm not able to really see the chat, or I'm back and forth with the chat, and it's just hard to, stay engaged with the content when I don't know what's going on with people chatting. Gotta answer this phone call, but I'll be right back. We'll see if anyone joins in a bit, and then they'll join to nothing, which will be funny. Okay, and I'm back. Let's get started. Let me zoom in a little so everyone can see. Let's see how this is. Seems good. So today we just dropped Learning Paths. That's cool animation. And we're gonna basically go through showing you guys what it is. Right now we only have. Oh. So when you go here, if you already solved a lot of questions, you're gonna get some achievements already. As you just saw, I got. But we only have a calculus for machine learning course right now. We plan to add a bunch of other paths, and these are basically to help you. So the point of these is to help you understand machine learning in general, but we want you to understand calculus, so you'll have a few, deep ML style questions. So you have these, and I'll take you through an order that will help you. So it goes from derivatives and gradients to multivariate calculus, neural network derivatives, graph propagation, and gradient descent, and so on and so forth. At the end of these, we have a few labs, and the point of the labs are twofold. One is to basically test your skills and see if you actually understood the concepts and can you apply them to more of a real world, thing. The second is basically to teach you PyTorch. So this way you actually have the mathematical understanding, and you also have, you have how to actually use them in a real world setting. So you'll learn PyTorch as well. The reason we have these, all these questions are available on the Problems tab and the Labs tab. You need to make sure nothing's, so what's the point of a learning path if we have it all here? And in my opinion, it's, we have over 300 questions at this point, and it's a little hard to know, what to actually solve, because there's just so much information. Which is a good thing to have. It's a nice problem to have. And, I'm using this platform too, so I try to, understand these concepts, and it's basically helping me become a better data scientist, machine learning engineer, whatever you want to call it. So it was becoming an issue for me. Like, the reason I started this was it's basically been an issue for me because I've been not knowing what to solve. Sometimes I did the random question. The daily question is always nice, just if you want to practice something random. But there was no, I guess, unifying path for anyone to study, and this way, if they study it, they'll be like, okay, hey, I know machine learning. I think the next few paths we're going to go with, sorry about that, we're probably going to do calculus, linear algebra, what did we do? Calculus, linear algebra, probability and statistics. Those are going to be the 3 math foundations. I'm trying to think if we should use a, what is it called? Like a basic programming one of these, like section 0 maybe, or like chapter 0 will be like basic programming. I don't know if our questions are made to teach basic programming. So I'm considering that, but right now it's going to be, we're going to start with math, then we're going to go to a machine learning section, then a deep learning section, and then we'll probably do some more specialized versions of these paths. So if you want to learn about LLMs, if you want to learn about maybe more traditional natural language processing, RL, yeah, we've got a lot of exciting things, I think, here. Oh, we could do RL, and then we could do deep reinforcement learning as well. And then RL will be focused on more of the traditional stuff, and then deep reinforcement learning is more of how deep learning, squished its way into reinforcement learning. So you guys listened to me babble for, I think, a while now. So let's get started with actually solving these questions. And we'll see how, well I'll do at these, I'm curious. Okay, so this is basic derivative of a polynomial. I probably should pull up a little drawing pad. So derivative of a polynomial, what is a polynomial, I guess, would be, let's see if I can draw nicely with a mouse. So you have like x to the third. This is an example of a polynomial, is x to the power of something. And then the derivative of this is you basically take this number up here and you move it over here. So it becomes 3x to the second. And that's how you take the derivative of a polynomial. I'm sure a lot of people know this already, but we're solving this question, and I'm going to try to, I guess, solve the question while also teaching the material. I don't know if that's super engagement for everyone, but I feel like for the people that don't know, calculus or things like that, it'll be helpful. I want to try to, help people understand these concepts while I also try to understand these concepts. So, and also if I'm able to teach you guys, I think that would be a nice way of me showing myself that I understand these things. But also solving these questions solve a similar thing. But let's continue. Let's just zoom in so everyone can see it. Implement a function. Yeah, that's still there. Implement a function that computes the derivative of polynomial terms of, so you have c times x to the n. At a given point x, where c is a coefficient, n is an exponent, okay. Okay. It's basically saying take the derivative of a polynomial. And the form will be, where is it? It's c, 2, so. Okay, and they'll plug in the x. So theoretically, it should just be n times x to the power of n minus 1. So basically taking n times c. Yeah, so it's n times c. And it's the same thing that I just showed you guys here. So you take, so right now here, in our imaginary example, n would be 1. So we take 3, we move it here, and then subtract 1 minus 3 up top, and that's how we get 3x squared. So I think that's the answer. I don't think this is such, I mean, it's an easy question, but it's good. Yeah, you got it right. It's a good way to understand the fundamentals. And we have little achievements on the side. Um, I mean, I think it's a fun way to experiment. I mean, some of these are harder to get and some of these are easier to get. Like I just got this one, which is pretty nice. Let's move on to the second question. And this one's a medium question. Product rule for derivatives. The product rule, let's see if I remember this without reviewing it. I think it's the first times derivative of the second. I know there's a little song, not a song, but some sort of song that, like the first times derivative of the second plus the second times derivative. Yeah, first times derivative of the second times derivative of the first. I'm trying to think of a good example. I guess like x squared times x to the third? No. It's more like, what's the eraser here? Erase. Oh, it's more like this. X to the third plus 3 x squared. I'm pretty sure it's something like this. So you take the derivative of the outside, the 2x, and then minus 1, which is just 1, so you just leave it blank, times the inside, x to the third. That's supposed to be a 3, yeah, plus, make this thinner. So it's the derivative of the outside, so that's this part. Maybe then you leave the inside the same. So derivative of the outside times the inside plus derivative of the inside, which is 3x to the 2. And since there's no x here, this just becomes 0. And that would be the derivative of this. So you need that product rule of the first, the outside times the derivative of the inside. I mean, derivative of the outside times the inside plus the derivative of the inside. At least I think that's what the product rule is, if I remember correctly. It's been a while since I've taken calculus. Keep on saying I'm in between stuff, but that's okay. I really think that this method of learning will be really beneficial to a lot of people. I think, like I feel like I do these rambles before and I'll do it again. If you're listening, congratulations, you get to listen to me ramble a little. People, like, I really think this method of learning will help people a lot more than just watching a course or reading a book even, because this you actually have to implement stuff, and it's trying to basically say, like, we're trying to follow a flow of, like, first polynomial, then product rule, and it'll take you through all of the things you're trying to learn. And you're doing it from a programmatic standpoint, so maybe it's not as beneficial as, pen and paper and solving these mathematical parts, but it's still beneficial and shows you how to use NumPy and how to just program in general, and while also teaching you the key math concepts you're going to need for machine learning. And like let me go back. Our, calculus for machine learning, I'm not saying you need to know all of calculus. Like, you could spend hours and hours and hours. And, I have spent a lot of time on calculus 1, 2, or 3. I don't know what numbers they go up to. But, you learn a lot. Like, there's a lot of, like, there's so much things within calculus. There's, I mean, there's not more than, like, just these, few classes that I'm giving, or these few sections. Like, calculus is a huge course, and there's, and it's interesting, it's very useful, I'd say, but you don't need all of calculus if you're trying to do machine learning. And a lot of textbooks, at least in my opinion, they teach you too much, which, why is that a bad thing? Yay, I'm learning more. But if your goal is to become a data scientist or machine learning engineer or researcher, you really don't need to spend all your time learning all of calculus. You could just spend it on a few key points and move on, so you could, get to the part that you want to study. And that's what we're doing here. But let's get back into solving this. Implement a function that computes the derivative of the product of two polynomial functions. Nice. Using the product rule from calculus, polynomials represent coefficients corresponding to the power of x, for example. Okay, so let's say we had a list 3, 2, 1. It would be basically from least, so from no x to 1x to x squared. Given two polynomials, so given f of x and g of x, and your function to return the coefficient of the derivative of the products f times, okay. I need to round it myself. Let me write, I don't like, let's continue. I don't actually know if you need to round it. Okay. Let's go. So here, so given. So let's take a snapshot of this. Let's break it down a little. There we go. So this is equivalent to 1 plus 2x, that's the f. Usually I type, but now you guys are getting to see my amazing handwriting, you're welcome. So this is f, this is f, and this is g. This is 3 plus 4x. I really need some sort of drawing pad or something. I do enjoy drawing. And we basically want to multiply these two things together. And that would look like 1 plus 2x. We'll do this on paper, pen and paper, and then we will do it programmatically. And it's similar to what we did before, probably a little easier even. So we take the derivative of the first. So the derivative of this whole thing is just 2, because there's usually a 1 up here, and there's 1, and if you do 1 times 2, that's 2, and this becomes a 0, and anything to the power of 0 equals 1. So this is 2 times 3 plus 4x, which is equivalent to 4, and our answer, so the derivative of this whole thing with the product rule is 6. So it's always going to be 6. It means it's a constant slope. Did I do that right? Oh. I just took the derivative of each of those. And that's exactly what not to do, as, that was a trick on my part. I was trying to get you guys, because I thought ahead that much to try and trick you like that. I basically took the derivative of both of these and multiplied them, and that's, not the product rule. The product rule is the first times derivative of the first times derivative of the second plus the second times derivative of the first. Ugh. What is it? It's the derivative of first times the second plus the second. Derivative of first times derivative of the first times the second plus the first times derivative of the second. Yeah, so here's the exact steps. It's take this, compute that. It's the first times derivative of the second plus the second times derivative of the first. That's, yeah, okay, that's the second of the first. So we'd have 1 plus 2x times derivative of the second, which we said was 4, plus the second, 3 plus 4x. And my handwriting's already terrible. And doing this with a mouse is making it not as bad as it should be, but still pretty bad. The second times derivative of the first times 2. So you have this, you multiply this out, and blah blah blah, combine like terms, do a bunch of fancy stuff. Should we do it? Fine. So this would be 4 plus 8x plus 6 plus 8x, and this would become 10 plus 16, that's a 6, x. And what are we supposed to return? I think we're just supposed to return the 10 and the 16. It's just supposed to return the coefficients. So let's see if we can do this quickly-ish. See how much of these we could get through today. Product rule. Okay, so what actually gets passed in? So this is what's actually getting passed in. So the first. This is weird without x's. I might think about if I should do notebook mode. Yeah, let's go into notebook mode. Because without the, like, I feel like mathematically it's easy, but then when I guess you're turning it to programming, it gets a little more tricky. And let's just take this and this. Throw a few cells down here. Call this A. Call this B. Okay. So let's think. It's the first. So I guess we're always assuming it's x. I wonder compute the derivative. I guess I'm just given, let's see, I'm just given a list of values. Like it's not, I guess I'm also only asked for the list at the end. What is this doing? Oh, this is doing it differently than I do it. Okay, but well, let's continue and see if my method would work or not. So I feel like doing this not on paper is a very different way of doing it than like doing it through programming, but I still think it's useful because it makes you program better. So the first would be 1, 2x. So it would be 1 plus 2. That would be the first times derivative of the second. I don't know why I can't think about this unless it's weird. Okay, let's just add the x's in. Set x equal to 1, and then we'll take it away later. So x, so it's theoretically, we have the first 1 plus 2x, 2 times x, times derivative of the second, which would be 4, plus derivative of the second, or the second times derivative of the first, which would be 3 plus 4x, and all of this would be times derivative of the first, which would be 2 times 2. I don't know if I love this question. Okay, because now it would be so the actual answer would be this would become 4 plus 8x plus 6 plus 8x, and this would be 10 plus 16x. So that would be the theoretical answer, and then we take the 10 and the 6 and we're done. But I guess we don't really have, yeah, we don't really have the x here. Making things stupidly complicated. But we will continue. Let's see. Compute, okay, maybe this is how you do it mathematically, but programmatically there's a better way to do it, which is what I'm guessing. Compute f prime of x, compute the derivatives, and then multiply them. Oh. Maybe I could do it my way. But I have to keep things a little separate, which makes it tricky. I'm going to need the first set of values and the second set of values, and they need to interact nicely. Theoretically with A and B, so I would need to do this. Okay, so let's take the derivative of each of these. So I guess I need a function that takes the derivative of any list of things. Okay. So if it's here, then it's just 4. If it's 5, then it would become 10. Because then you take the 2 and you're moving it down. Okay. I'm not hating this question as much as I thought I would. So, take this. What would the derivatives be? Derivatives would be let's go derivative. I'll take in a list. And for I in, call it x. For I in x, in range length of x, we will, okay, so making a function to get the derivatives of any list. So for I in range length of x, so we're going to basically go iterate through each of these and take it to the power of I. So for example, so we do x of 0 to the power of I. Is that all it is? Because then, okay, we're in the first position. So x of 0, so that, x of 0, x of I to the power of I. I guess this works because we don't really need to care so much. Okay, because we're just getting the coefficients. We're not really getting that x component. So yeah, this would work. So we would take a. So a is the first value right here. So there'd be 1 to the power of 0. And that makes sense because I feel like this is getting confused. Let me make sure everyone's on the same page here. I'm going to show this again. So we have A is 1, 2, 3. And A is 1, 2, 3. Same thing as saying X. Oh, no. Saying 1 plus 2x plus 3x to the second. And I did this because this is the 0 place, this is the first place, this is the first place, second place, third place. So this is x to the power, so theoretically there should be a little x to the power of 0 here, but anything to the power of 0 is 1, so this is 1 times 1, which is 1. Here, there's a little 1 on top of here, so it's 0, 1, 2. And that's all A means. So this is A. We can do something similar for B, but I think you guys understand the concept. Now, what our function does is basically takes the derivative. So it looks at position 1, takes the derivative, and the derivative of this, so let me erase that x here because it is just annoying me. The derivative, f prime, is, so derivative of 1 is 0, plus derivative of 2x to the 1 is just 2, plus 6x. So all we would need, so we drop the 0. We probably don't drop the 0, because then we probably have 0, comma, 2, comma, 6. And this would give us the same representation as we had before, and so this is the same as this. So now we are taking the derivative, or at least getting the coefficient of the derivative. Yeah, this should work. Trying to think what to name the list to store these values in. F of x, dx. That works. This will be a list, and dx dot append this, and we will return dx. So now theoretically we should be able to take the derivative of any of these functions, or any of these lists. So derivative of a, not a, just a, is 129. Let's see. Zero, 2, 6, yes, that makes a lot more sense. It's like, where did I go wrong? Further, okay. Let's continue. So now we can take the derivative. We have a function that takes the derivative. Now we take the derivative of f of x, g of x. I think we just, let's move this. Let's move to the regular mode again. Just make a new function right here. Okay, so now we can take derivative of the f coefficients. Oh, hey, thanks for commenting. Thanks for joining. I'll give a quick intro because we have a few more listeners right now on what we're doing. We basically introduced something called paths on DeepML. Right now we only have the calculus for machine learning path, and we're just going through it and trying to solve all the questions. I don't know if we're going to get to all of them now, but we're trying, and we plan to add a few new sections as well. So we're going to start with the math. We start with calculus, linear algebra, and probability. After that, we'll add some more like machine learning section, deep learning section, and so on. I mentioned this earlier, but I have a few more viewers right now, so I thought I'd give a little recap. But we're in middle. I should have solved this. That would have been not that bad if I forgot it. So right now we're taking the product rule. Doing it programmatically is a little more interesting than doing it mathematically. At least for me, because I didn't know how to do it. Derivative of this. So this is, let's say, f of x. Not d of x, not d of f. Derivative of f, d of f, and we have dg. So we have those two. So now we need element-wise multiplication. Let me see, does that... No, I didn't save my work. No, I didn't. So if I have a list 1, 2, 3, and I multiply it with another list, 2, 1, 2. Will this do what I want it to do? Okay, let's say I did an NumPy, NP array. This. This. Okay, then it works nicely. So let's do it like that. So we have the derivatives, and we have these values. So first value, df underscore g equals derivative of the first, df times the second. So df times np dot array g coefficient. Oh. That would have been a small annoying mistake. Let's continue. dg f. It's going to be this, pretty much the same thing, except we switch. Except we just switch up the names. So this would be dg, and this would be f coefficients. So now, where are we? So we did this, we did this. Okay, so then so these would both be arrays, so I think we should be able to just add these two together and get our answer. At least that's what I'm hoping for right now. Okay, I got 2 of them correct, but I got 3 wrong. So I got 0 and 16. I should have got 10 and 16. Let's see where I went wrong. Just copy this over to notebook mode. Let's see if I got the derivative right. Print df dg. So that's 0, 2 and 0, 4. 0, 2 and 0, 4. And then I'm taking df times g coefficients what am I missing? So it's, I think I'm getting the second value correct. Just the first value I'm doing wrong. Are these 1x? I feel like it said. Let's see. Yeah, that makes sense. Okay, polynomial multiplication. You're using element-wise multiplication. Okay, I understand the. I want to fix this issue first. I don't think it should implement the shift though. You're just repeating yourself? Oh. Okay. So right now I'm just, so theoretically, what is it? So I'm not, yeah, I'm supposed to do it like this. Which is just an annoying thing to have to do. Like I would need to go 1 times 3, and then 1 times 4, and then 2 times 3, then 2 times... See if there's any NumPy packages that could help me out a little with this, because I feel like it's just semantically annoying. Oh, here we go. So, I mean, this won't give you the solutions. Like, I can ask for the answer, it's not going to give it to me. But it will give me, like, useful information. I'll be right back. Give me a sec, guys. And I'm back. Sorry. Okay, so I feel like a little break was also nice because I got annoyed because it seems annoying to have to do, but maybe NP convol whatever could help us out. Let's see. Um, Sometimes I love myself for making things, sometimes I'm like, it's a little annoying. So right now it's generating a question based on my request. And I'll randomly do this when it thinks it would help me learn. Oh, and for some reason it failed. And that's even more interesting. I don't even know if it's working. Everything's a bug. Oh no, it's not. I mean, it didn't generate a question, but it's telling us the information needed. I think it, I guess, just took a little longer for some reason. Okay, so it takes A and B and returns the coefficients of the product polynomial. Wait, can I just do... Okay, let's play around with this whole convolutional, whatever this thing is. 3, 8, 10. Let's say I took this one. Oh. So, I think it was this. This is what we needed. Okay. If we do 1, 2, 3, 4, we should get 3, 10, 8. And then take... Wait, what? Okay, this is saying take the derivative of f, take the derivative of g, take the derivative of this, take the derivative of that. Okay, so if we took the derivative of these two things, so it's 1x, it would be 1 plus 2x, this would be 2 times... This would be 2 times... No. Okay. Getting closer. Getting closer, everyone. see, let's see. Into whatever. Save this. Should have it save automatically. Grab this. We're currently working on. And where were we? Okay, that's an issue. It keeps on getting overwritten. Is it getting overwritten? Save. Go back here. Show 4 cells. That's an issue. Alright, yeah, we need to fix that. That's not nice. That's just mean. Should at least save it in the cached. Yeah, so be a little bit careful for the notebook mode. So right now we're taking the derivatives, we're doing this. So df oh, it's plus. So that's the first thing. Adding these. No. This is that. Okay, fine. Back to what we were doing before. Save. Okay, so let's see what we're actually doing. So this takes derivative. So we're taking the derivatives and we're returning the coefficient values, which is good. I need to, I guess, understand, because right now I feel like I'm trying to jump through this a little too much. I don't really know what convol does in NumPy. I feel like I'm just like, okay, magical function that magically works, and I'm just hoping to throw stuff at the wall and see what sticks instead of actually learning it. Which is my bad. I'm trying to get better at it, but you know, we all try to take some shortcuts sometimes. Okay, what it does, it takes two coefficients, a and b, and returns the coefficients of the product polynomial. So result k is a of I times... I still don't get it. Okay. Thinks I still don't get the question. you have to use this. Again, and the reason we have the AI tutor is just so you don't use ChatGPT, not as like, oh, I want to stay on this site and not use ChatGPT and lose people. Like, yeah, maybe it's part of it, but the more things, because I feel like if you asked this line of questioning, it would just tell you, oh, hey, this is how you're doing it. This is exactly what you're looking for. Here, at least, there's a little barrier to learning. Like, it still makes you read stuff and try to understand stuff and implement it. Let's see. Okay. Let's try this. I just wanted it to go there. This. I got 0366, which is correct, but you know, that leading 0. And here I got 010. Okay, so am I always gonna get a 0? I guess so. So we really don't need. Do this until. I guess we'll start out. No. I think that should work. Oh, wrong way. There's some cuts from the end. Just a regular one. I guess we just try and cut off the first one, 366. Okay. Maybe this will work. We could also submit from here. Let's see if we're any closer. It's funny that mathematically I feel like I knew what to do, but programmatically I was really, I guess, unsure how to actually do it. So close. Where did I fail? Okay, we're just going to be. I'm going to be annoying about this. Not the nicest thing if. Let's say if length of f, whatever. Let's do result equals this. And then if length of results is it equals 1. Return result. Else we're doing that. Okay. Let's run this and let's submit it. Let's see how we did. Nice. Still making it through. But I feel like I still don't fully understand. I feel like I got it right, so maybe I should just. Please tell me my. I guess I have my solution here. Here we go. I still don't understand this fully. I'm pretty sure. This is my understanding right now. Like we have. Let's say we have 2 plus 3x and 4 plus 2x, and what the numpy function does, because theoretically this is supposed to be 2 times 4, then 2 times 2x. This would, just some quick math, 8 plus 4x plus, so we're just doing this, 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 this. And I'm pretty sure that's all what the npconv whatever thing was doing. This would be 12x plus 6x squared. So we should do 8, 16, I don't remember what I put there. 6, okay, plus. So this should theoretically be in that list form. 8, comma, 16, comma, 6. So let's see, let's do that. np dot was it? And in our example, we did 2, 3, 4, 2. 2, comma, 3, comma, 4, comma, 2. 8, 16, and we got 18. Nice. Okay. So I did understand what I was doing. I just see, and I feel like that. Yeah, I feel like sometimes I'm like guessing what it's doing, and I'm not 100% sure, but I'm like 80% sure, and I try it out, and then I sort of forget. Like I didn't really fully understand it, but now I actually understand, how this works, and I'm sure that this will pop up again in our journey. So it's good to understand it now versus not understanding it later. Let's see. Now we got the quotient rule, and we got gradient. Which one's this? Gradient detection and magnitude. So this is a mix. In my mind, it's a mix of. Trying to think, would I do this? Yeah. I'd say this should be category. Should be calculus. Okay. I mean, I guess I have a few of these complete already, but I still want to go through everything. Just lab 12. I guess one of these labs is probably lab 12. Okay. I know if I go through this, I'm going to sort of try and take some shortcuts. I'm probably not going to do this now. Also, I need to fix this because today's Thursday, right? Yes, today's Thursday. Okay. So I need to fix this up because this is wrong. It should be Thursday, not Friday. I was like, is today Friday? But yeah, this is our, our paths. Again, you can access it from the problems page. It's right here. Learning paths has a cool animation while you go over it. And this, right now we only have calculus. And it's only the calculus you really need for machine learning. It's no extra fun stuff. Maybe we should have added, a few annoying things here and there, but I think this is the actual foundation you need to understand calculus. At the end, we have some labs testing your skills and also basically helping you understand how to do these things in PyTorch. Because I feel like PyTorch is the main language people are using for, deep learning these days and machine learning. So the point of the pass is to walk you through, like all these questions, I said this before, but I'll say it again. All the questions are available in problems. It's just hard to know what order to do them in. The learning path is meant to basically help you determine, which labs to do, which problems to do, what order to do them in. Yeah, and we're going to add a lot more of these. I just wanted to show you guys how it worked. I plan to go through these, like I plan to solve this calculus section fully. After that, we'll go through the linear algebra and the probability and so on. But let me know what you guys think about it. Let me know if it's helpful. I feel like, to me, it's really helpful because, again, I think we have not too many questions, but we have 330 questions, and it's hard to know what actually to solve. And, I mean, we do have collections, and I think collections are useful for smaller subsets of things you want to study. But for a complete path that we're building, I think like this learning path will help a lot of people. And I think it'll help a lot of people that don't really know a lot about, or like they know some machine learning, they know some math, they know some coding. Like I guess the prerequisite here is that you know Python. But other than that, you should be able to solve these questions. I think with the help of like the tutor mode or the breakdown, you should be able to solve most of these. I do want to add, because I think, let me show you here. I do really want to add playgrounds to the calculus questions, so I'll probably work on those now. This way the path is more complete. And the playgrounds just let you, play around with different concepts so you can understand how it's actually working behind the hood. In my mind, it's better than a video because you can't really play around with this aimlessly and pretend like you know something. You actually need to interact with this, and you're like, okay, so this 1, 2, 3, and now, oh, this is 1, 2, 3, and gives you some sense of understanding. But you have to actually look at it, and there's no like passive watching or passive learning. With a playground, you have to actually, you don't have to, but it's more engaging and it's harder for you to think you understand something while you don't really understand something. It's easier for you to know you understand something. With that, I think we're good. Does anyone have any questions or comments or concerns? The notebook mode, I'd say look out for right now. There's a bug where it's not saving your information. So just be careful to copy and paste stuff, but we're going to work on fixing that as soon as possible because that's dangerous. Because I don't want people to write a bunch of code there and then lose all of it. Okay. I think that's it. Thank you guys for joining. Thank you guys for using the site.